Hey there, and welcome back to Codeverse, where we make C++ simple, powerful, and fun to learn. In today's video, we're diving into one of the most flexible and beginner-friendly tools in the C++ world, vectors, also known as dynamic arrays. If you've ever felt limited by fixed-size arrays or frustrated by memory issues, this lesson is going to unlock a whole new level of control in your programs. So grab your keyboard, let's master vectors together. So what exactly are vectors in C++? Think of them as smart, modern arrays, but with superpowers. A vector is a dynamic array. It can grow or shrink in size while your program is running. You don't need to know ahead of time how many items you'll store, just start adding, and it will expand automatically. It's like having a magical container that resizes itself as you drop new elements in. Internally, vectors manage memory efficiently, often allocating extra space to avoid resizing too frequently. And thanks to the power of the standard template library, or STL, vectors also come with useful functions, .push_back, .size, .clear, and more. With vectors, you get flexibility, performance, and cleaner code, all in one package. That's why modern C++ developers use vectors in nearly every real-world project, from game engines to database tools to embedded systems. In short, if you're still using only basic arrays in C++, you're missing out. Now that you understand what vectors are, let's talk about why they're better than traditional arrays in most real-world C++ projects. First, arrays in C++ are static. Their size is fixed at the time of declaration. That means once you define int arr, 5, you're stuck with just 5 slots. If your program suddenly needs more, tough luck, you'd need to allocate new memory manually, copy over the old data, and manage everything yourself. Vectors, on the other hand, are dynamic. They handle resizing for you. Want to add more elements? Just use .push_back, no memory headaches, no bounds to worry about. Second, arrays lack built-in functionality. Want to know how many elements you've stored? With an array, you have to track that manually. With vectors, you just call .size, simple and reliable. Third, arrays don't come with safety features. If you access an index out of bounds, C++ won't stop you, which can crash your program or corrupt memory. Vectors offer better safety with optional checks, especially when using .at, instead of the square brackets. And finally, vectors are part of the standard template library, which means they're well-tested, portable, and ready for professional applications, from small tools to complex systems. So in summary, vectors grow dynamically. They come with built-in tools. They're safer and more powerful. And they make your code easier to write and maintain. That's why modern C++ developers almost always prefer vectors over raw arrays. Alright, now let's get hands-on and learn how to declare and initialize vectors in C++. First, to use vectors, we need to include the correct header. That's, include the vector. This gives you access to the full power of dynamic arrays in C++. To declare a vector, you use this format, std, vector int numbers. This creates a vector of integers named numbers. You can now add values to it anytime. Want to initialize a vector with values right away? Just pass them in using curly braces, std, vector int scores equals 90, 85, 78. This vector starts with 3 values, and you can still add more using .push_back. You can also create a vector of a specific size, filled with a default value. Like this, std, vector int ratings, 5, 3, this gives you a vector with 5 elements, each one initialized to the number 3. Vectors work with any type, not just int. You can make vectors of double, string, char, even your own custom classes. Just remember, every time you use std, vector, you're building a flexible, memory-safe list you can grow and manipulate without worrying about low-level memory issues. Declaring and initializing vectors is easy, and once you've got the basics down, you can start writing powerful programs that scale with your needs. Now that we've declared and initialized vectors, let's learn how to add and remove elements dynamically. This is where vectors really shine compared to regular arrays. First, adding elements. The most common method is push_back. It appends a new element to the end of the vector. Example, numbers.push_back, 42, just like that, 42 is added to the vector. You can call push_back as many times as you want, the vector will automatically resize to hold all the new values. If you want to insert an element at a specific position, use the insert method. For example, numbers.insert, numbers.begin, +1, 99, this will insert the value 99 at position 1, shifting the others to the right. Now let's remove elements. To remove the last element, use pop_back, numbers.pop_back, one call and the last value disappears. To remove an element at a specific position, use erase, numbers.erase, numbers.begin, +2, that deletes the element at index 2, and everything after it shifts left. You can even clear the whole vector using clear, numbers.clear, this removes all elements, but the vector itself still exists and is ready to be reused. And don't worry, behind the scenes, the C++ standard library handles all the memory management for you. So whether you're building a list of users, game objects, scores, or anything else, vectors let you grow and shrink your data on the fly. Fast, flexible, and incredibly powerful. Now that you've learned how to add and remove elements from a vector, it's time to learn how to access the elements inside. The most common way is using the index operator, the square brackets, numbers, 0, accesses the first element. Numbers, 1, gives you the second, and so on. But remember, vector indices always start at 0, just like arrays. If you try to access an element outside the valid range using brackets, your program may crash or behave unexpectedly, there's no safety check. That's why C++ also provides the .at method, numbers.at, 2, safely returns the third element, and if the index is out of bounds, it throws a proper exception. Want to get the first or last item directly? Use these convenient methods. Numbers.front returns the first element. Numbers.back returns the last element. These are cleaner and easier to read than hard-coding index positions. And don't forget, you can also loop through a vector to access all elements one by one. Using a for loop or a range-based for makes your code neat and readable. Whether you're accessing one value or looping through hundreds, vectors make it easy and safe to work with dynamic data. Now let's focus on one of the most important skills when working with vectors, iteration, going through each element, one by one. Imagine you have a vector full of numbers, or strings, or even custom objects, and you want to print each value, perform calculations, or apply some logic. In C++, there are several powerful ways to iterate through a vector. First up, the classic for loop, for, int I equals 0, I less than vec.size, plus I. std, cout vec, I, std, end L. This gives you full control over the index and is perfect when you need to know the position of each element. Next, we have the range-based for loop, introduced in C++ 11, for, int number, vec. std, cout number std, end L. It's clean, safe, and ideal when you just want to access each item without worrying about the index. Want to modify the original values in the vector? Use a reference in your range-based loop, for, int address of number, vec. Number pointer equals 2. This actually changes the values inside the vector, not just copies. And for more advanced control, you can even use iterators, for, auto it equals vec.begin, it not equal to vec.end, plus it. std, cout pointer it std, end L. Iterators are especially useful when working with complex data types, custom containers, or STL algorithms. The way you choose to iterate depends on your goal, whether it's performance, simplicity, or modifying data in place. The key takeaway is, vectors in C++ give you multiple elegant ways to loop through data, so pick the one that makes your code clean, clear, and effective. Now it's time to bring everything together with a live coding example using vectors. We'll build a simple program that asks the user for a few numbers, stores them in a vector, then prints the values and calculates the average. Let's start by including the necessary headers, include diastream. Include the vector. Then, inside the main function, we'll declare an empty vector, std, vector int numbers. Next, we'll use a loop to let the user enter values. For example, we can ask for 5 numbers, for, int I equals 0, I less than 5, plus I. Int input, std, cout enter number, I plus 1 colon, std, int input, numbers.push_back, input. This loop collects the values and adds them to the vector using push_back. Now, let's display the contents of the vector, std, cout you entered, for, int number, numbers. Std, cout number. Std, cout std, end L, finally, we'll compute the average, int sum equals 0, for, int number, numbers. Sum plus equals number. Double average equals static underscore cast double, sum, slash numbers dot size, std, cout average, average std, end L, and that's it. You've just seen how to use a vector to store, display, and process user input in a real C++ program. Simple logic, modern syntax, and no need to manage array sizes manually. Vectors make your code cleaner, safer, and easier to scale. Alright, it's time to lock in your learning with a quick mini quiz. Let's test how well you understand vectors in C++. I'll ask you a few short questions, and you can pause the video to think about your answer before we reveal it. Ready? Let's go. Question 1. What function would you use to add a new element to the end of a vector? Answer, push_back. Question 2. What's the difference between numbers, 2, and numbers.at2? Answer, numbers, 2, gives direct access without bounds checking, it may crash if the index is invalid. Numbers.at2 is safer, it throws an exception if the index is out of bounds. Question 3. How do you loop through a vector without using an index? Answer, use a range-based for loop, for, int number, numbers. Question 4. What method removes the last element from a vector? Answer, pop_back. Final question, how do you remove all elements from a vector at once? Answer, use the clear method. Great job. If you got most of those right, you've definitely started mastering vectors. But don't stop now, the next topic will unlock even more power in your C++ toolkit. Stay with me. You've learned a lot about vectors, from what they are, how to declare and use them, to powerful techniques like adding, removing, and iterating. Now it's time for your final challenge. Here's your task, write a C++ program that asks the user to enter as many numbers as they want, until they type -1 to stop. The program should store all numbers in a vector. Then, it should do the following, print how many numbers the user entered. Display all the numbers using a loop. Show the smallest and largest number. Calculate and display the average. That's it, a real-world use of everything we've covered in this video. Don't worry, take your time. Pause the video and try it on your own. When you're done, resume, and I'll walk you through one possible solution. This is how you level up as a C++ developer, not just watching, but writing, testing, and solving real problems. You got this. Let's go. Awesome work, you've just completed one of the most important topics in modern C++, vectors, the dynamic arrays that make your programs powerful and flexible. You now know how to declare and initialize vectors. Add and remove elements. Access and loop through vector data. Solve real problems using vectors in real code. You didn't just learn syntax, you built the skills to handle collections of data like a pro. In the next video, we'll take things one step further. And show you how to group different variables into your own custom data types using something called structs. It's your first step into the world of object-oriented programming, and it's gonna be powerful. Until then, keep practicing, stay curious, and keep coding. See you in the next one.